My distinguished students, you are once again welcome to our lesson series in Math 106. Today's topic shall be on hypergeometric probability distribution, another way of probability concept. Hope you enjoy the lesson as we go along. Thank you. My name is Dr. David Banjon from the Department of Mathematics, Faculty of Science, Lagos State University. At the end of this lesson, you should be able to know hypergeometric distribution, means of hypergeometric distribution, variance of hypergeometric distributions. In this lesson, you shall be introduced to a method of distribution that looks like that of binomial distribution but not exactly alike. This is called hypergeometric distribution. Suppose you have n items, m of which are defective and n minus m are non-defective. Suppose that you choose small n items from the big N items without replacement. Let x be the number of defective items found among the small n chosen items. Suppose you obtain x equals to x defective items and therefore n minus x non-defective items among the chosen small n items, which then implies that the x must come from the m defective and n minus x must come from the bigger n minus m defectives. You have the probability that x take the value x equals to be as that in expression 4.01. The hypergeometric distribution is a discrete probability distribution that describes the probability of k successes in n number of trials without replacement from the finite population of size capital N that contains exactly k objects with the future wherein each trial is either a success or a failure, compared with binomial distribution in which replacement does occur. The following examples will give you an instant grasp of what is being said above. An uncontained 4 red balls and 10 blue balls. 5 balls are drawn at random without replacement from this on. What is the probability that exactly 2 red balls are drawn? Solution. The probability that such a selection results in 2 red balls and hence 3 blue balls is simply 0.35964 using the formula given above. Suppose a random variable x is defined as the number of red balls obtained when 5 balls are drawn without replacement from the above. The above problem then asks of the value of px equals to 2 and the solution is just 0.35964. The random variable x defined here is said to have a hypergeometric distribution with parameter n is equals to 14, m is equals to 4, and the number of those objects that have is specified. Attributes being read and n equals to by the number of objects selected. This can be written briefly as x hypergeometry 1445. Example: a statistical department has purchased 24 calculators, of which 4 are defective calculators, are selected one after the other without replacement and tested. What is probably that the second calculator to be found defective is 8 calculators selected. Using the formula given above, you find the probability to be 0.079051 as the mean of hypergeometric distribution is given by n times m over capital N. The variance of any given hypergeometric distribution is given by the expression here, sigma square, where p is equals to m divided by n and q is equals to 1 minus n divided by n. When n minus n divided by n minus 1 is small, the variance is just equal to npq, which is the normal square root of the npq. The standard deviation is the square root of the variance denoted by this expression. The mode of the distribution is defined as the most likely number of objects in any given sample space of size n. Say this is the largest integer k such that k is less than n plus 1 times m plus 1 divided by capital N plus 2, sometimes denoted by n bracket closes n plus 1 times m plus 1 divided by capital N plus 2. If k is an integer, then the hypergeometric distribution is bimodal, that is, the values of k and k minus 1 will be the two modes. 3.03 example. At a college, there are 18 fresh students and 12 classrooms. The lecturer chose 20 people at random to orientate these students. In this group of 21, what are the possibilities for the number of students orientated? What is the probability of there being exactly 12 students to be orientated? See, what is the most likely number of students orientated in a sample size of 20? D. In similar scenario of this orientation, what are the average number of students oriented, and the standard deviation is the number of students oriented. Using the probabilities for A, because 20 are chosen and there are only 12 classrooms, then at least 8 students must be chosen. So anywhere from 8 to 18 students may be orientated. B. Using the hypergeometric formula for calculating probabilities, the probability of exactly 12 students and hence 8 classrooms being posted is 0.30584. The denominator comes from the total number of ways of choosing 20 people from 30. The numerator comes from choosing 12 and 12 out of 18 students and choosing 8 from 12 classrooms. The most likely number of students orientated will be k equals to 20 plus 1 times 18 plus 1 divided by 30 plus 2, which will give you exactly 12. And the standard deviation, as well as defined above, is just 1 point, which is the square root of variance, is just 1.287. You have the following activities which you need to do in order for better understanding of this subject, and you are expected to do them as soon as possible. The notation of replacement or no replacement has been clearly stated in the hypergeometric distribution. The non-replacement of sample points is always taken into consideration. Clearly, at the end of this lesson, the way hypergeometric distribution works in generating probabilities, means, and standard deviation of any given sample space should be easier for you to handle. My distinguished students, for reference purpose, please refer to the following previous lessons, lesson note, courseware. Thank you.